All right, good morning. It is week 8, day 4, 2 months down after today. It's impressive. Time flies when we're having fun, huh? Today, we are going to be revisiting something you've done once already, got a little base intro to Docker. Um, Today, we're going to jump back into Docker because now that y'all have been learning about front end and you did some back end API work with Python, I think it was day 2. I have that up here. Um, we're going to learn how to kind of package this up so everybody can use your server. Um, we're specifically looking at just the server portion right now. So if we hop back to day 2, and you remember you had this HTTP server challenge where you had to try to create a server or modify. You had to modify this server here to add an endpoint that when visited would return back a JSON of your current time. So you should have built that, but if not, we will go ahead and do that together in a second because we're going to make this server and then we're going to package it up so everybody in the world can use it on their own local machine. Because as we all know, we're on different operating systems. We have different dependencies installed. Some might be missing, some might have conflicting dependencies that don't work with what you need to run the server. So Docker makes that all really simple and no, let's go back up to the top and kind of packages everything in an image that anybody can pull down from Docker Hub and run on their computer. It will have everything, the whole environment all together, so they don't need to do anything besides just pull down that image and run it. So we are going to start off in our VS Code today. I've already set up the files necessary, but we're going to have that server .python file. And if you all want to follow along so you can get the solution to that challenge the other day, feel free to. Otherwise, you can just watch because the important part is going to be when we start making our Docker file for it. Um, so y'all remember your intro to Docker, right? You remember building an image
Mhm.
with a Python base. So we're kind of going to be doing the same thing again today, but let's start with our server. So let me go back to that challenge and grab what they had given you initially. Okay. So this is what you were given in your challenge server file. And they wanted you to add another endpoint on here that when visited, um, it would go ahead and give you that JSON response with the time. So looking at this, it can seem kind of overwhelming and confusing, especially when you're looking at all this socket stuff. You might be like, I don't know what a socket is. I don't know what all this bind and whatnot. That's okay. You don't have to know about this stuff. This is kind of just built in. It's something you can kind of copy paste. It's setting up a server and it's binding it to a specific port. So this will pretty much stay the same. Um, what else do we have going on here? What's an important part of this server that we can see um, that kind of builds our endpoints for us? Where are all of our endpoints stored in this server? It's up towards the top here. If you were saying something, Cisco, you're muted.
Am, aren't I? They're stored within the request class call.
Correct. So we have a class up here that we've called request. And underneath request, we could see it's initialized. Um, this also might look crazy. to y'all, but that's okay. It's actually pretty simple. Each request, when this request class is set up, it expects to receive a request text. Um, in order for our endpoints to be able to understand what we're targeting, it needs to go ahead and parse that text. So it's decoding it here, and then it parses it there. That also is going to be similar terminology or similar setup data structure for every kind of server request class you build, because the request is not just going to be a simple get this endpoint. There's a whole bunch of headers and extra stuff in that request that comes in, and you need to look through it and grab what you want specifically, what is important. If we come down here, this server, so tell me, is all this one thing? Is this all together? Like, does this server stuff belong to this class? No, I see Nicole shaking her head. No, that's correct. We can see that's at the same level as this class. Why is that not indented? Oh, because it doesn't, let's see here. This is supposed to be,
Yeah, that's
we,
separate, Tiffany.
okay. I was
It's
like,
not within the
that's,
class.
oh,
I
okay.
know it.
Okay. So yeah, these are all separate. These are happening on their own, but we do have a function that's sticking out on its own here that helps build the responses from these requests. Um, but this server, again, is set up on its own. And as soon as the server is set up and running, this is missing a whole bunch. Oh, no, it's not. We have the server listen down here. Okay. So while true, just keeps this whole portion down here running. Right here, we have the server that we've set up right here, set to listen. And while it's listening, it's going to say, okay, waiting for a request on this local host. It's listening for any client connection, and it will accept that connection. And the request is going to be in this class request, where it's going to take the request information from this client connection and go ahead and initialize it. So it decodes it and then it parses it. Here is the meat of the endpoints that we're hitting. So these are the important parts here. If that request is going to just like a slash, so that's going to look like what, localhost and then the port slash, right? So this is what it means if this URI ends with a slash. So if it has nothing after words, then we're going to go ahead and send it to the build HTML request function. And it looks like we're passing in hello world. So this is one of the endpoints. We're going to build our HTML response, sorry, not request, response. We're going to take that hello world and we create an HTML body that we're going to return and serve up in a way that the browser can go ahead and just slap that HTML in the browser. It's going to take that text and place it in the body here. Look, we have our HTML tags around the whole outside. We have our head here, which we learned about the head. We could stick our title in, and any other, like if you have style sheets, sorry, like an in file CSS styling or some JavaScript functions, you stick that in the head. Then we have our body here. So it's an HTML document. It's just all on one line here. But that doesn't matter. The spacing usually that you do in your HTML files are just for visual It's just to help you see it visually. Spacing doesn't matter in the HTML here. You can, as you can see, it's all in one line. As long as you have the opening and closing tags in appropriate positions, this is going to be a whole HTML page. All this jazz here, this 200's the return code, that's an OK code. You'll learn more about this kind of stuff later. It's content types, a header, it's like a text HTML page. The length is going to be the length of the body. All this will kind of stay the same if you're serving up an HTML page. This is what would change. So that's what happens when we visit just the base URL. Now you're supposed to build in another endpoint that whenever they go to this /time, they're not going to go build an HTML response. This time you want to build a JSON response because you want to return JSON of the current time. So let's go ahead and build that out because we could see how this kind of did here. We're going to do the same thing right here. We're going to do a client connection and send it to a different function we're writing here. So let's call this, we'll keep it with what they've done previously here with this build HTML response. We're going to build a JSON response now. And then that is eventually what we're going to call down here. So let's do a client connection and send the name of we're going to do build JSON response. And then this has dot encode. We're going to go ahead and throw that on here too, because probably need that with the Python. I meant to do this. We're calling the function dot encode. Okay. So that looks similar to what we did up here. Let's go ahead and build our function, and then we can test this and see if it works. So in order to get the current time, what do I have to do first?
Time by time, time.time.
Enough time? Okay, let's go ahead and assign that to a variable so that we can use that later in the function. Is it time.time? Not sure that's
date time.
dot date time, or should I just do dot time?
Date time.
Okay.
Now. And the now function.
All right. So let's see what this gives us. Okay. Print statements are awesome. I'm gonna comment out our server right now because I just want to test this build JSON response function to see. I'm gonna call it because I want to see what this current time shows. Text body. Is it because I don't have build HTML response yet? Let's get that commented out too. What the? Oh, I'm calling the wrong, it's too early. I'm calling the wrong function. We're trying to call this JSON response one. Okay, so that's what that gives us. We can see our current time variable now stores our current time down to like, what, milliseconds? So that is perfect. That's what we want. We want current time. But now we want to be able to return that as a JSON response. So right now, if I were to return that right now, it would be like Python object, right? It's not going to be in JSON. So we have to have some way to be able to translate that into JSON so that when it pops up on our screen, it's going to be in JSON format. So Python has a built-in thing. We'll say our JSON body. It's called JSON dumps. So this just takes and makes a JSON for lack of a more detailed description. But I'm going to pass in our current time. Excuse me. So it's going to take this that we printed out down here and translate it into JSON for us. So now we can return, I can't just return JSON body because look, we had to do something special up here, right? We had to have like this HTTP response and a 200 code and OK and all of that. And there's going to be some other things in there that could kind of catch us too. But let's go ahead and try to do something similar to this. We're going to change a couple of things though. Okay, so these are probably still going to be the same. But then we come down to content type. This is not a text HTML content type. So that needs to change. This is going to actually be an application slash, yes, JSON content type. So that's different there, content type. And then content length. It's not going to be the length of an HTML body because I don't have that. Is going to now be the length of this JSON body. And then at the end, we have this HTML body down here. This is the response. So I'm just going to go ahead and change that to JSON body as well because we're returning up JSON. So theoretically, this should be all I need. And we can go ahead and test this and see if this works. So let's spin up our, am I in the right location? Yes, Dockerized. I'm going to spin up, actually, I'm just going to push play. Okay, so we know it's working, right? Because we set it so that while the server is active and listening, it prints waiting for a request on this local host. Thank you, VS Code, for making it easy so I could just open in browser. But if you don't, that was 9292. If you don't hit that fast enough, you could just go to localhost colon 9292. It was being a little funny for me earlier. Is that that is the, oh, it shut down. So we can see my server's not running anymore, right? It shut down here. Let's see if that is that. None type object is not subscriptable. What does that mean? Oh, I did not plan on doing a whole bunch of troubleshooting here.
We can help you out, Tiffany.
Did you all fix this yourself? Is that
Yes. So as it as it stood, the server was broken, and that was the first step for us to do is to actually fix that error right there that you're getting.
got it?
So yeah. So that being said, let's see. Could you scroll up to the parse request? So yeah, see that parse request?
Oh,
Yeah,
equals
with none.
none.
So you want to change that to let's see. Well, first you need to create a request line above that. Request
Actually,
line.
I'm just gonna steal what they have in today's README,
Okay.
and we can walk
Yeah,
through it together
that'll
and
work
see what
too.
they
Yeah.
do. So this is what they did. In order to parse the request, they took anything that was URI. So the URI is going to equal this decoded request text, which we're getting from up here. It's taking the first item in that request that we've split on spaces. And then it's also taking the second item as well. So we can, I don't want to eat up too much time doing this, but you could, let's do it. Yes. First. Okay. So when I'm running this server here now, let's go back to my browser that was broken. I'm going to try to put this on this side and we'll get this. Oh, this is not pretty. I'm trying to see. Okay. So when I come visit here, now we print out this parsed request. We can see down in the terminal here, there's actually a few times, don't worry about this favcon ICO, you'll see that a lot. But the initial one is it took right here, this is what it's doing. It's saying URI, and then it's taking the request, splitting apart all those different things that I said comes in with that request, and it's pulling out, it pulled out that first item, split it on spaces, and then returned the second item in that first item, split on space, which equals this. Let's see. Let's go ahead and print this decoded request text too, so we could see that. And anytime you make a change to this server file, you have to stop it and restart it because it will not just automatically update while the server's running. Okay, so let's, yes. Okay, so this whole thing here is the request. Okay, so that's why you decode it here and we're passing it into this part. This is why we have to parse it, because all of this stuff, we don't need a lot of these headers that they pass in right now to point us to the endpoint we need to get to. The important part is this first thing here. It's saying it's a GET request to just this slash endpoint, and then HTTP, that's fine. But so we took this in this decoded request text, we took this first item in the list, which is this whole segment here, and we split it on spaces, because if you notice, there's a space in between each of these items here. And then we took the second one, which is the endpoint. That's the important part. The endpoint we're trying to hit, just the slash. So then we break that down in our parsing the request and say, okay, it's a slash. Then my server knows anytime it's just that slash for the URI, it's going to go ahead and hook up with that build HTML response. Now let's go to our time and see if that works. I don't think it will because we're missing something. It's thinking, it's trying to. All right, so it doesn't look like it's wanting to do anything. Let me clear this. Control C. And we'll start it again. What is something we think we forgot here? Oh, I didn't need to do that. Ah, okay. So now we got an error. This can help us. Object of type datetime is not JSON serializable. So we have to do something because we can't just take, let's go back up here. Is the split screen bothering y'all? I can put it back full screen, but so we can't just take a date time. It's saying we can't turn a date time into JSON. But what we can turn into JSON is string text. Okay, so let's go ahead and just change this into string. We'll start there and see if that helps. Okay, let's kick up the server again. Oh, I'm not calling it in the command line. I can just, okay. So now we're gonna go straight to it. Let's see what we got there. Hey, it works now. Perfect. I guess it did work. Sometimes you might have issues with CORS errors. You'll see that come in from time to time. It's the access control for your server. A lot of times servers don't like receiving access or connection requests from other locations. So my browser is not on the same port as what the server is on. So it might sometimes throw a little issue or error. So if you see in today's README, in their JSON response, they have a header here called access control or allow origin, and then the star. The star means everything. So what this header does in this response is it's saying that we are allowing all connections to go ahead and get this information, and it's fine. But you will see that more when we get into Django and do some more build out of our servers. This is not how we're going to end up with our servers in the future. This is just a quick little socket server just to kind of show you what a backend could look like. We're going to be using Django with Python to build out a bit more beefy server, but the idea will be the same, that we'll have separate endpoints that people will hit by going to different URLs. And each endpoint will have its own function or response given depending on how that's set up. So that is how we solved the server thing. So now that we've got the server up and running, this should work, right? On everybody else's computer, I could just give them the server file and we're fine and good and dandy. No, no. They might have an old Python that doesn't work with some of the stuff we're using here. They, operating systems, all that kind of stuff can throw a wrench in our plans. So we're going to take the server that we know works on our local machine, and we are going to throw it in a Docker image now. And this is, let's see. So do we remember anything about our Docker images? Do we remember any important key things that we need to start off with our Docker file? What's kind of the like at the center of all Docker files? I know it's been a few weeks ago, but So let me go to, let me pull this up on the other screen first before I pull it back over here.
Yeah,
Let's just,
one of the things is you need to specify what I guess what language and operating system you want to use.
yeah. So the language and operating system. So I just went to Docker Hub here and I just searched Python because that's kind of what we're using now. But the core base of all Docker things is that we have all these images that are pre-built. So Docker images that are made for us to be able to use. And as Cisco was saying, an important base to our Docker file is that we're using Python. We want everybody to be able to run Python, our Python script or server on their own machine. So we can borrow an image that was already built for us, and this is an official image. So this is, this is the real deal. This is Python packaged up in a way that everybody will be able to run our image and Python should work just fine. But the core to every Docker file is you need a base image to kind of have everything else run off of. Because if we just start throwing stuff in here without an image, nothing's going to work. So we're using Python, right? That's what our server is founded on. It's Python. So that is the very bottom layer of our image here. The first thing we have to do is we have to point to this image. So how we can do that is we just say from, that's the keyword, from, and you can pick any image out there on Docker Hub. You choose a JavaScript. You can choose an HTML one, I'm sure, and build an HTML thing real quick, but we want to use Python. So there are lots of Python images we can use. If we go back into Python here, we could come down and see these are all different Python images we can pull down and build off of. If you just put Python, it should pull up just the latest, greatest version of that image. But we want to have a little bit more granular control over what image we're using. So we could see Alpine's got a lot of tags here. So that sounds pretty good. We're going to use Alpine because it is a super small base image. So you got to remember also when building your Docker files that any image you build off of, it still has to like install this, basically take up space on wherever you're going to be running this image. So the smaller you can use, like your base image is, the better time you'll have adding other things, and you won't fill up the server with a very large bloated image. So Python's a very small, or sorry, Alpine is a very small Python image that we can go ahead and build off of. And it has everything we need because it's Python. We're going to keep using what the README has. We could try, I didn't try running with some of the newer Alpine versions, but just to go ahead and not break anything and make sure everything's running smoothly as they expect, we're going to use this 3.11 Alpine image. Okay, so first things first, I'm taking a base image. Basically, it's going to be whatever language you're writing in or what operating system you're working on once we get to more advanced things here. Or not operating image, or operating system, I'm sorry. We'll go into that in another lecture. But for our server, we're using what we wrote the server in, which is Python. So first things first, we have that image that we're pulling from. And now we need to install dependencies and copy over our application code because this image is just Python. It doesn't have anything else yet. If I spun this up right now, it's just going to give us a Python shell that we can work in, basically. We don't want that. We want our server to run using Python, right? So first things first, we're going to have to set up a work directory where we're going to put everything in. This is going to be inside our image, okay? Because it needs, just like our server lives under our directory we've named here, we need a directory that we can put it inside our image as well. Can't just float out there and nowhere. So standard convention here is we just put it in source. And that is inside this image. There is a directory named source. So we're just pointing and telling it to drop it in that directory there. But what do we want to drop in that directory? Can anybody take a guess? We're working on trying to have our server, which is Python, running in an image. We've got Python set up. We've got a directory now set up that we're going to put stuff in. What do I need to put in that directory?
Your actual server.
Correct. I need to get this file here, our server that we've written, into this directory so I could do things with it. So let's go ahead and copy that. So Docker files, when you run this Docker file, it's going to look at the same level that it is in your directory tree. So when I run this, I'm going to try to copy server into this source. So we need a copy from location and a copy to location. Okay. My copy from location, if I run this file, it's going to look right here where it's at. So we could say stay in this current directory and grab that server file. Okay. So it's going to take from where we're at here, this server, and it's going to copy it to this source. Now, because we set our working directory to source, so we've set up a Python image. Inside this Python image, there's a source location. When we said work directory source, it brought us to that directory. So we don't have to say, put this in source, or we just say, put it right here, because we're already in there in the image. So we are copying from where we're running this file into where we're working. Okay. So I'm sorry, the work directory creates a directory, it says, but in this we're creating a source. I'm pretty sure it already contains one. We could see, and then we copy it from the local machine to the container. We already said this dot means where we're at in our working directory. Awesome. So now we've got Python going. Python's running. We've got our directory that we've put our server into. If I want this server to be running, what do I have to do? What do we do when we want this server to run down here in the command line? If I'm here in my own machine and I want this server to be running, what do I have to do?
Python server.py.
Yep,
Run
I
it.
have to run the file, right? Usually we do like a Python and insert, right? And then that's running it. So we need to do the same thing here because we want it to be running. Right now we've copied it and it's sitting there, but now we want to start it up. So this line, we're going to do a command. We're going to tell this image to run a command. And it's set up inside brackets. And you said, let's see, the first part here, we're going to say Python. And then you separate it by comma. And then the second part, server.py. So this is going to call Python and then run this file. This is also going to be pretty much a copy paste thing for all your Docker files. This is how you set up the command to run a Python file. Okay, so do we think we're done now? We've got Python installed. We've got our working directory. We've taken our server and put it in that working directory, and then we've basically told it to run the server. That's all we wanted, right? We just want our server to run. So I think we're good. This should be good. This is all we need in our Docker file. It seems really simple and basic, but that's what this is here for. It's supposed to be simple and easy to use. So now that we have this Docker file, we can't just run Docker files like we run our Python files. Doesn't work like that. We have to run it the Docker way, which we have to build this first. After you make a Docker file, first thing you do is build the image, because this Docker file is going to make an image like this. So Python's an image. This Docker file will create another image. And that's kind of like a hodgepodge image. It's not going to be just a Python image. It's going to be like, gosh, let's see if we can just, I'm not going to search, but it will build, I'll come to my hub. It's going to build a different image that's anybody can grab from Docker Hub and run on their machine. So yes, Art, question.
I believe we were working in the terminal before to build up this image. But when I was looking at the desktop, it seemed like I could see the same information in the desktop version as I saw in the terminal. And I preferred, I guess I'm just so used to like GUI type stuff that I preferred the desktop. Can we work exclusively in the desktop, or do we have to still use the terminal?
I would switch to the terminal, get outside your comfort zone, because in the future, you're going to want to write scripts that automate this kind of build and startup of your Docker images. So if you have to go into a GUI to do all this stuff, to start up an application, it's going to be slow. It's not going to like coordinate well. But eventually we will help you write scripts that will tell the Docker image to build, to run, and then in a sequence, because when we're working on just a server right now, right? We're building just a server image, but the end goal of this course is you're going to have a front end image as well, and then you're going to have another, so you'll have a server that's going to work between the front end and the back end. So this server one we're working on now, let's call it backend. This API server is your backend. So you're going to have a backend Docker file, a front end Docker file, and then a server Docker file that works as the like connection between the two. So I know it's comfortable using Docker Hub or the Docker desktop, but it doesn't make sense in the long run to do that in practice. But it's okay, save, like bookmark these things if you want in a folder for easy reference later to find these like commands that help you build it. Because these don't change much. These will stay pretty static throughout the course. Well, we might add a few more things here and there. So good question though. Nothing wrong with the UI. It's just, it limits you in the long run. So yes, building our image. That's the next thing we have to do because we want to build this and then run it. So the README has the command in there. Let's throw it down here. So it says Docker build -t and then username homegrown dot. What does all this mean? First off, there's a space in the front of this, it looks like. So Docker build, it's not going to change. That's how we're telling Docker to go ahead and build a Docker file. This -t is the name that we're giving this image. And this username /homegrown. So Docker Hub, if you want to push something to your own Docker Hub, you have to name your image with your username in Docker / whatever you want. So my username in Docker Hub is Tiffany Joel. So that's what I'm going to throw on the front of every single image I build to make sure that when I push it to Docker, it will land in my Docker Hub. Okay. Can't use anybody. Why is it not coming up? I'm trying to get, okay, here. So we can see all of these start with my username in my Docker Hub. You can find it by logging into Docker Hub or pulling up your desktop and, seeing what you've set as your username. So use that to name all of your images. Because if you try to name it something else, like somebody else's name, or not include this username, it will not land in your Docker Hub repos. It either won't build because you don't have permission to push into whoever else's repository you're trying to put it into, or it won't land where you expect it to. So we've got Docker build, we've given it a name, which is my username for my Docker Hub. You'll change for yours. And then we're calling this just homegrown, I guess. And then the last thing is this dot. So what this is saying is look where I'm at currently for a Docker file. Because wherever you run this Docker build, it's going to look in that directory and automatically find anything named Docker file. So it's easiest to run it while you're in the current directory that your Docker file is, but you can run it outside this directory. You can run it anywhere. You just have to point to what directory holds that Docker file that you want to run. Okay? Any questions so far? So I'm just going to go ahead and build this image. And we can see it does a whole bunch of stuff. This is pulling down basically dependencies and everything we need from this base image we've told it to work off of. Okay, so we told it to get everything from this Python image, and then we're going to go ahead and make our working directory, which it did down here, copy our server into there, and wrote our own image, named it. So this is good. You should see a whole bunch of blue on your screen. Everything should be successful at this point. So I should have a Docker image on my system right now. Does anybody know how I can check if I have this image on my computer? Did y'all learn the command?
Type in Docker images.
Yes. So I can type in Docker images, and we can see I do have a image that I built called Tiffany Joelle Homegrown. This is the image ID it was given, and I created it about a minute ago, and this is how large a size that image is. So this is great. I got my image, but it is not running right now. If I were to go to, let's see, in our server, we said it was localhost, localhost 9292. It's not running, right? All I've done so far, I'm not running this image. I just built it. So now I have an image that's built, but I need to be able to run to it. Or sorry, run the image. So now we can do Docker. Did not mean to, I typed in something else. Now we can do Docker run. Going to tell it to run. I have this --rm. This is just an optional tag. You don't have to include this when you're running this image, but basically this is going to tell when you stop running this image, this is going to remove it as well. It deletes it after it shuts down. So you can go ahead and include that if you want. It's just a nice little cleanup thing, but you don't have to include it either, because at the end of this lecture, I'm going to show you a nice little script you can put into your shell, into your bash shell profile, and it will go ahead and clean up all your Docker stuff for you. So we're going to Docker run this -d. Does anybody know what that flag does?
It runs it in the background.
Yes, runs it in the background in daemon mode or whatever. So when we called our server earlier, oh, I don't have it here, but remember when we called or ran our server, it kept throwing out a whole bunch of stuff in the terminal, right? I don't want to see that. I just want this running without any sort of output anywhere at this point. You may not do that when you run an image on a like in your future job. You probably want logging and everything. So you may not run it in daemon mode, but for our purposes, we don't want to clog up anything. And then we're going to pass in this -p is port mapping. So our server expects to receive requests on 9292, right? So we're gonna just say this is where we're going to, what port we're going to use on our local host, and then what port it's going to go to inside the container. Because you could think about it this way, this Docker image is separate from our computer, but the Docker image is expecting this request to come through on 9292. We could give this a different port on our local host. So if we went to our local host, we could go to like 8543 and it would map to what the server expects in the Docker image. You may have to do that eventually, but right now let's just keep it the same, okay? Because we know 9292 on my local host was open. It was fine. It was not being used by anything else. So I'm just going to go to 9292 on my local host, and it will go ahead and hook up into the container when it's running and hit the container's 9292. Does that make sense? Are we all following this port mapping? Okay. So then that should be all. Oh, no, it shouldn't be all. So I've got Docker run. I've got all these additional optional flags. The port is not optional. You need to have that port mapping there. Now we need to actually give it the image that we want to run. So it's easiest to grab it by the name that we've given it. So we're going to run this homegrown. Okay. So when I push enter, we can see it spit out a whole bunch of stuff and it tells me my application's running. Don't see anything here in the terminal, but that's because we told it to run silently and not fill up our terminal with output. Another way I can see if this is actually running, we can look at our Docker instances, our containers that are up and running. This Docker PS or Docker PS-A will show you containers that you have. Docker PS will show you containers you have running. Docker PS-A, I think, shows you images that are not running, but that you have. So we can see here, I had this image, this Docker image I built, but now this is the actual instance of this container running on my machine. The image is just what we're basing or what we're asking the computer to run. This is the actual instance of it running. Yes, Art.
So if somebody were to send me, like let's say you were to send me this Docker file, I need to run this on my machine. So I would be putting in these --rm --p, and I would assign it a port on my machine. So I mean, is that accurate? I mean, I need to know these steps when I receive a Docker file, correct?
Yeah, absolutely. Usually there are, let's see, let's go back to Docker Hub. Let's see if I can go back to Python. A lot of times there are, where is it? References, how to use this image. Okay. So if you get a Docker file from somebody to run, there should be like documentation on how to use it, what it expects in order to run. So you would just visit this area of the image to get that, or just have whoever sent you the file tell you what it needs, if it needs a port mapping, or if you can just run it as is.
Okay. Okay, thank you.
Mhm. Okay, so we get the difference between an image and an instance of this container running, correct? Okay, this is not the image, this is the container that is running. So gives it a container ID, and that's how you target this container. It's built off this image. The command that it ran is python server.py. Let me go ahead and get out of that program. It was created 23 seconds ago. It's been up for 22 seconds. Here's the port mapping we set up. We say anything that's coming that I put through port 9292 on my machine is going to go to 9292 in the container. And then it gives it a random name. It's these are the wildest names you'll see. Youthful Stonebreaker. I would not recommend targeting these individual names. I would target the container ID when doing anything with this container. But this is running. This tells me it is. If I do Docker on the screen, Docker PS again, we'll see now it's been up for 3 minutes. So it's still running. It says it's up. So now I can go to my page here. I'm going to refresh this, and we can see it's running on my machine. I'm able to hit this 9292, just the slash, and it gives me the hello world. And then if I go to time, it goes, oh, pretty print. Oh, it didn't change it. I've never seen that. But it gives us our time returned. So this, our server is working. It's running. It's serving up what I need it to do. Awesome. So how we can stop this is we can, I think we just Docker stop. I can't ever remember and as long as you only have one or even a few containers running, you can just put in the first few characters of this container ID and it will know which one you're referring to. So I just Docker stop that image or that instance, sorry, container running, it's thinking. So what it's doing right now is it's shutting everything down. It's stopping the server. So now when I go back to Docker PS, I can see no containers are up and running. When I go back to Docker PS-A, oh, it's gone because we told it to. So that RM command, this is what it does, is it removes that container instance. If you didn't have that -rm, your container would still exist in this PS-A. It would just be stopped and not running. But you could spin it back up. If you just stop it, you could always start it again, start the same container again instead of calling it down from this image. So now that I've got this image built locally, I want to share it with the world. I want to give it to y'all to be able to pull down and use my server that I've built for you. So now we're going to go ahead and push it to our Docker Hub. Because we've set it up with this name of your username / whatever, you can literally just Docker push and the image that you built. And as long as your Docker's hooked up well and working, it will go ahead and you can see it's using a default tag. It's calling this the latest. This is what I meant when you do the from Python. We could have just left it like this. And what it would do is basically pull the latest one that was pushed up. So that's what it did down here. It built the latest repository and it pushed it to my library. So now if I go back into Docker Hub, scroll up, come to my hub, we should see homegrown, and it was pushed a minute ago. And this is public. Now everybody can use this image. But how do I do that? How do I use this image? Super easy. So first things first, I'm going to make sure there's nothing Docker related left on my computer because I want to show you how you can pull down that image and use it. Okay, so first if we go to, we checked here, right? There's nothing running, no containers that I need to kill or delete, so we're good there. But if I come to Docker images, we could still see my image is still there. I'm going to go ahead and remove that image, 9C5. So then it went ahead and untagged it and deleted it. So now when I run Docker images, I have no Docker images on my computer. Okay, so the one I built here and pushed up to Docker Hub, it's gone. I have no images. I could rerun the build from this Docker file, but I don't want to. I want to pull down the one that I have on Docker Hub. Super easy to do. All I have to do is Docker run. We'll pass in all the same tags that we had before, the port, 3292. And I just have to give it the name of that image on Docker Hub. So this exists on Docker Hub. So I am able to just say Docker run that image, and it's going to tap into Docker Hub, look for an image with this name, and then run it on my machine. What did I do? Oh, what? Oh, because I only have one dash. It's two dashes. So what it did is it said, I can't find this image locally. It always looks on your computer first to see if you already have that image cached. So if I had that image still locally here, it would have just seen it here and said, okay, let's go ahead and, let's do nothing because you have it. You're fine. It's not going to run it. This is, or yes, it is going to run it. I'm sorry, we're running the run command. So it would come to this here locally and run it if you had it. But it said, you don't have it. Okay, let's go pull the latest of this image. These are already cached on my system. Don't worry about that. That's just pulling all those Python dependencies that we needed to run this image. And then it downloaded that image. And this kind of looks familiar, huh? This is what we saw earlier when we ran our locally built image. Okay, so we have done two separate things here. We built it locally and ran it on our machine and it worked. We pushed it to Docker Hub and deleted the local version, right? We don't have the local version anymore. And now this time we are running the Docker Hub version that we just pulled down. So now if I go back to my, it's still running. It's still working because we ran the image pulled down from Docker Hub. So any questions there? Okay, so somebody run me, oh, yes.
Well, if you were to run like the Docker images now, that image would show up.
Yep. Because it needs that image locally to run it. But if you don't have it locally, it's going to pull it down and build it locally for you.
Is your container running or is your container open as well?
Yep, has to be if I'm able to hook up to the server, but we could check. Yes, it is. So this Docker run is the command to run the image in an instance.
Okay. Okay, thank you.
Yes, that was a great question. So by doing Docker run, I was telling it, go ahead and spin up an instance of this image. So that is why it is already running without me doing anything, all those extra steps. Before, okay, so I want somebody, give me a rundown of the steps I would need to take if I just built a server and I want to, and I've made, okay, no, I want you to walk me through the whole process. I want to go through so we can kind of solidify our steps here after we built a server. Oh, wait, no, let's stop this first. I don't want this Docker image running forever, so we're gonna go ahead and Docker stop it. And that was EC4. Okay. Don't forget to stop your images, especially if it's a server. It'll eat up resources. Okay, so now let's do PS. This -A will show you even stopped instances, so it's a good one to check because it will show everything. Cool. Okay, so now let's go back and revisit. I just built a server file. What are my steps to get somebody else to run my file? That's the first thing we did.
So they need to build it or install, or they need to pull it from the Docker hub.
Okay, nope, let's back up. What's the
Okay.
first? I have nothing except my server file. That's all I have right now.
Oh, okay. So
What's the
you
very first thing I need to do?
create a Docker file.
Yep, so first we need to create a Docker file. And info, I guess, whatever. So first things first, you make your Docker file. Okay, I've made a Docker file. What's the next thing I had to do?
Build the image.
Build the image, correct. Yep, so next we had to build the image. Make sure you give it that T, which gives it a name of your username. Dash, whatever. Who you call it. Okay, so we created our Docker file. We built an image, and that was the Docker build command, which in our README you can find the Docker build command and just make sure you kind of follow that outline. What did I have to do after building the image? Now, we did a lot of steps in between, but I'm just looking for the process now to get somebody else to run this image on their machine. So after I build the image, what do I have to do next?
It should keep off the hub.
Yes, correct. We would push to Docker Hub. And you could, for good measure, run the image locally just to make sure it works. It's always actually a very good idea to make sure your image works locally before you push to Docker Hub. But I just want the high level. Actually, let's throw that in there. That's not a good to do. Let's make it a requirement. We're gonna make that a requirement. Run it locally. Make sure it works. Because if your image doesn't work locally, it's not going to work on Docker Hub. So after you build it, run it locally, make sure it's working like you expect it to, push it to Docker Hub, and then what does the person have to do now?
Now they can pull it.
Yeah, now they can pull it. And how do they pull it?
Docker pull.
They could do Docker pull. Yep. So we just did Docker run and had it automatically reach out. But if you don't want to run the image immediately, you can definitely just pull the image first, as Cisco said. So we would then either pull image or and Docker run image. That's all it takes. That's the process. In between running it, make sure you stop images. Otherwise, it starts eating up a lot of space. And before you know it, you'll go Docker images and you'll have like a huge list of random images. Any questions on the process of building our Docker file, or creating a Docker file, building our image, running it, pushing it, pulling it? Yes, Art.
I kind of got tripped up the last time we were talking about Docker because I kept forgetting that dot space at the end of the file. Like right where you're at right now, that dot space, but then there's another location where that has to be included. Um, is that is that when you're actually like on your line two or line 13, I should say. Um, do you have to do a dot or a space dot after that as well?
Let's see. Let's go back to the. I do not memorize these commands because I don't use Docker enough here. So I have bookmarked all of these. So for the build image, yes. If we look at the README, so this one's using a dot. But what is that dot telling it? Like, what does Docker build expect?
That's saying use the local version, right? Or pull from the local file.
Not quite. So
It's
it's,
saying
oh, go ahead, Cisco.
no, it's basically saying that you want to build that to the current directory. Yeah, I believe.
So let me, now you're gonna have me second guessing myself, but
Is
I,
volume for anyone else?
What's that, Joe?
You're pretty low volume for me. I'm not sure for anyone else.
Okay. How about that?
Much better.
All right, thanks.
okay. So yes, I was on track. I'm not second guessing myself anymore. So the command is, if I were to just run Docker build, I could do this. Docker build dot. So this dot is saying where that Docker file exists. Where should it look when I'm running that command? Where should it look for a Docker file? So that dot means our current directory, because we're running this in our Dockerized API directory, which has a Docker file. If I make another directory and move Docker file into there, now it's not at the same level that I'm at. It's kind of buried. So if I were to do Docker build, first off, this wouldn't work anymore, right? Because the Docker file is not in the same location as that server file. So I would have to go back and get the path to the server file. So that wouldn't work. We'd have to change that. But then also, if I'm running this out here under this directory, if I said Docker build dot and using this current directory, it's going to look here and say, I don't see a Docker file. I can't build it. So that is where we do Docker, like passing the path that you would point to for that Docker file. Because now under Docker, we could see that's where our Docker file lives. So you don't, if you're running this in the same directory as your Docker file, which makes it super easy, and I would always recommend doing, you would use the dot there. Now, this command that we have in our README adds a tag, which is what you need to get that name to be what you want it to be. If you just do docker build dot, it's going to give it a random name. It's probably going to be like Python and something because it's using the Python image. But we use this -t to give it a name that will hook it up to our Docker hub. But that is a good question. Yes, these dots are easy to forget. But you will quickly remember to use them when you try to do a Docker build and give it a name and then run it. And it's going to be like, I can't find a Docker file because you didn't tell it where to look. All right, any other questions? Last things last is we talked about, when we're doing all this like building and pulling images and stuff like that, we're going to get a lot of stuff building up in here, like image wise and container wise. I just have Docker image or images. I just have one right now, but this could grow. At the bottom of the README is a very easy little clean method that you can add to your bash profile. Do y'all remember how to get into your bash profile? Nope. Okay. So I wonder if I could just run it in this terminal here. Code that. Perfect. Okay, so if you just do that code squiggly line dot slash bash profile, if you are using a bash profile, it will have a lot of stuff in here. I'm using like the Windows subsystem Linux, so it doesn't use bash profile. Mine uses what does it use? Like BR. I'm trying to remember what it's called now. Did I not write it down? I updated mine and I didn't write down. Bash RC, that's what mine is. When Windows subsystem Linux often uses a different profile, which overwrites the bash one. So I don't have anything in here. Don't say. I'm going to go to mine, but if you guys code that profile and you have stuff in there, that's where you're going to drop this code that it gives you on the bottom of our README. I'm going to open my bash RC because that's where mine is. What? No, maybe it's not. What is it? I swore that was it. Let me see. I need to find the command to see this. Oh, maybe no, that shouldn't have anything to do with it. Okay, it's because I wasn't in the right. I was in a Python one. I wasn't in Bash. But it should, your profile, your Bash profile should kind of look like this, where it has a whole bunch of stuff in it. If you just scroll to the bottom and throw in this clean method at the bottom of the README, what this does is it has all those commands that we used to stop and remove images. It throws it all in one and it's targeting everything. So this PS-A-Q is grabbing all containers and all images. So then if you were to just do clean in the terminal, so Docker stop I didn't have anything running, so it didn't do anything. Docker RM, I didn't have any containers because we had that flag earlier that removed it anyways, but it did remove the image I have on this machine. So now when I run Docker images, it's all gone. So this clean basically cleans every single Docker image and instance off of your machine. It's super helpful because if you start getting some clashing running instances, it's not fun. But that is in the bottom of the README. That's a cleanup that you can add. And if anybody needs help trying to find their bash profile or whatever profile that you use, just let me know. But any other questions before I stop recording and we go over the challenge for the day? Make sure if you add it in there to save if it doesn't automatically save before closing out. And then you need to kill your terminal and restart it for that to take into effect. So don't be like, why is it not cleaning? All right, I'm gonna stop recording now.